Good morning, everyone here. I hope you all are doing well. And I welcome you to Tech Webinar with TimesPro. So today, we have a session on a very trending topic that is large language models and generative AI. We will be talking about approaches, metrics, and career implications. So let me introduce to our esteemed speaker for today's session, Mr. Kaushik Bar. Kaushik is a co-founder of Inside Out, an AI startup with dev centers in Bangalore and Kolkata. He works there as the CTO and chief data scientist and responsible for AI and Gen AI innovations, tech roadmap, and thought leaderships as well. He is an ex-Intel and ex-SanDisk, as he has a total of 2 decades of experience in enabling data-driven decision making in organizations of different sizes. Kaushik has a US patent in storage tech and built a product which got featured in Mashable's Best Tech of the Year in 2017. He architected an AI based finance automation solution which got awarded by the European Association of Corporate Treasurers. He has led global AI solutions for multiple industries across several functions horizontals. He has also, in his current organization, he created a Gen AI powered conversation intelligence accelerator, which is currently being used by many firms in the automotive space. Kaushik is also a gold medalist, MBA from IIM Bangalore, and has an engineering degree in electronics from Jadavpur University. Today, Kaushik will be shedding lights on fundamentals of LLMs and why they hallucinate, implications of hallucination and how hallucination is different from other LLM safety issues, and hallucination mitigation strategies for implementing practical business applications with real life examples. So let's give a warm welcome to Mr. Kaushik as we embark on this enlightening webinar journey together. Over to you, Mr. Kaushik.
Thanks, Ekta, for the introduction. Thanks for having me here. And thanks to TimesPro for organizing this. Um, hello, everyone. Thanks for joining in. Hope my screen is visible. So,
Yes.
today we will discuss about hallucinations in LLMs. LLMs or large language models are the bedrock of generative AI. In this session, we will discuss about hallucinations, some metrics to measure hallucinations, and some strategies to mitigate hallucinations for real life business scenarios. Right? Okay. The introduction has already been given by Ekta. Thanks for that. And please feel free to connect with me over LinkedIn. Link probably will be provided anyway. Okay, so this is our agenda today. Initially, I had thought of delivering the core content first and the career implications at the end, but then later I decided to turn it upside down. So I will start with the market landscape and the industry dynamics given the advent of LLMs and Gen AI, etc. And then discuss about the career implications and why this session will be important for your career. And then I'll jump to briefly introducing some of the fundamentals of LLMs, which will be important to understand the why, what, and how parts of LLM and then discuss more metrics, to measure hallucinations and ways to mitigate hallucinations for practical business scenarios. If you have any questions, please feel free to write those in the chat window and we can take them up in the Q&A section towards the end. With that said, let's move to the content of today's topic. Let's discuss the career implications. First, let's understand the current market landscape. Gen AI market is estimated to grow 10 times over the next 8 years. And in terms of the percentage of total tech spend, it is estimated to quadruple during the same period. Much of the Gen AI driven improvements will come in the areas of customer experience, automation based reductions, cost reductions and innovations. Companies will look for implementing Gen AI solutions via external tech partnerships as well as in-house capabilities. Therefore, it is prudent to learn about how best we can leverage LLMs and how we can make LLMs more reliable. Companies are looking for people who can implement reliable GenAI solutions free of hallucinations, and that's why sessions like these are very relevant for those who are looking to work in these areas. The space is exciting and there are a lot of opportunities, but broad multidisciplinary skill sets are required to exploit the opportunity. What do I mean by that? With GenAI, people no longer need advanced research background for building useful business applications. Anyone can build it, and the GenAI has democratized the knowledge to everyone, which is an opportunity as well as a risk, depending on how you look at it and how you prepare yourself in view of the changing industry dynamics at play. Fears that competition will be there, because even though the first mover will gain the most, there will be smart late movers who may leapfrog to catch up, like what has happened for Google versus OpenAI. Google was the first mover in the NLP and text processing space. They released the seminal paper on word embeddings, right? It was Google researchers who released the paper on attention and therefore were largely responsible for the transformer architecture, which all of today's LLMs are based upon. They had also released BERT, which was one of the most successful transformer based models. But today, OpenAI has taken over, and Google is still struggling to get back into the race. So if you are late, no need to lose hope. Keep working hard and you may catch up. And if you are slightly ahead, consolidate that and keep doing newer things so that you continue to remain ahead. We have to also understand that even though foundation models will be created by big tech, and what is foundation model anyway, if you are not aware, we will cover that. Um, Foundation models will be created by big tech companies with deep pockets, but there will still be a long tail of small firms or talented individuals creating innovative solutions for specific business problems. Ability to find those business problems would remain key, like it has always been. Therefore, in terms of technical skills, multidisciplinary skill set across the entire gamut of AI involving data science plus data engineering plus UI plus DevOps or MLOps will be important. Deep tech expertise will continue to be valued if you really have enough depth. Knowledge of how things work will help you to tweak models better for your specific business requirements and innovate more. However, ability to design for scalability and operationalizability will be even more important than what it is today. Knowledge of multiple software infrastructure systems will also be critical because integration will be key. The software aspects of the non-tech skills like exploratory mindset, ability to imagine, and ability to translate business problems into AI problems will continue to remain important. Domain expertise will remain important, and whatever you do, user experience will be the key. So, overall, as I mentioned, in order to be able to design and implement practical business applications using GenAI, we need to learn about LLMs and how we can mitigate hallucinations of LLMs so that our applications are operationalizable. And that's the relevance of today's session. Now, before going into hallucinations, let's understand what LLMs are so that we can understand why they are prone to hallucinations. Let's start from the basics. We have evolved from rule-based systems to traditional ML algorithms like logistic regression to self-supervised deep learning-based models to today's ChatGPT and the likes, which use RLHF-based models such as GPT-4. In each transition across generations, what has fundamentally changed is the share of learnable portion in the overall system. In this diagram, blocks that can learn from data or are trainable are marked in gray. Okay. As we can see in the rule-based systems, everything was manually designed and no learning from the data was happening. In classical ML systems, like logistic regression, the feature engineering was being designed manually by a data scientist. But the mapping of those features to the output, that is, which features are significant and which ones are not, was being learned from the data. With deep learning, the features were also being learned from the data by using some embeddings model, which could represent texts as numbers or vectors. But the loss function was still being decided and designed by a data scientist. Finally, right now, the state of the art models like GPT-4 use reinforcement learning with human feedback, where the loss function also is learnable from the data. So, what next? That's a food for thought. Maybe the input data itself will be uh, marked gray in the next iteration. Because if models are to become autonomous, like you would expect in case of AGI or artificial general intelligence, then the model should be able to train themselves. And for that to happen, a model will need to be able to pick and choose which data it should utilize to train itself. So, but that's a future research topic. And, anyone in today's session thinking about doing research in these areas, probably this is a food for thought. Let's move to the next slide. We started out saying that we will first discuss what LLMs are so that we can understand why hallucinations happen. But and so that we can understand um, the details about hallucination and approaches and metrics later on. But defining large language models is not easy for two reasons. First, what is large? What is considered large today may not be considered large tomorrow. But one of the successful language models of the pre-ChatGPT era used to be considered large, right? But now it is not considered as large anymore because there are much larger models available today. So perception of what is large changes over time. And second, it is also not possible to define LLM based on its capabilities because as LLMs scale, certain capabilities appear all of a sudden. That's called phase change events in LLM parlance. For example, by looking at GPT-2 or GPT-3 capabilities, one would have expected that we probably are more than a decade away from reaching the capabilities that GPT-4 is showing within just a few years. Now, if you define something and then the underlying assumptions of the definition get invalidated within a few months, then such a definition is of no use, right? That's why researchers today focus on the fundamentals, which will remain valid at least for a few years. So, on the right side of this slide, I have mentioned four fundamental axioms, and each of these axioms is elaborated in the subsequent slides. First, LLMs can understand languages. It can be a human language like English or a programming language like Python or even multimodal languages, especially for models that can convert text to image or text to video or speech to text, etc. And the capabilities change all of a sudden, as I mentioned before. This sudden acceleration in capabilities makes it difficult to define LLMs. Second, training of LLMs may involve many sequential stages with compute complexity for each subsequent stages going down as it reaches from generic training to task specific training to finally use case specific training. Third, it is not theoretically proven but empirically seen that just by training more parameters on more data over longer duration, better results with the same model architecture can be achieved. This is the scaling laws of the LLMs. And finally, all LLMs so far follow the transformer architecture, which I'm sure many of you are aware of. The scope of today's session obviously doesn't allow discussion on transformer architecture, but we will show a simplified version of it definitely. These are four axioms. Now let's delve deep into each of these axioms. The left side on this slide shows relevant accuracy metrics for several models across multiple task categories versus model scale measured in terms of number of floating point operations. As we can see, there are model scale thresholds, um, after which a sudden change occurs across all these charts, right? It is as if a sudden performance emerges after crossing these scale levels. Yeah. Before that, models were, performing in a way that makes engineers believe that the learning is not really happening because the learning curve is pretty horizontal, even if we scale training. So the main takeaway from this slide is that engineers need to make experimentations easy to rerun in the future as soon as any new model comes out, so that any prior intuitions based on prior observations can be reevaluated, because nothing is permanent in the highly dynamic world of LLMs. Now, there are multiple sequential stages for training an LLM, and as we go from top to bottom in this slide, the data involved moves closer to the specific use case. Pre-training is done by organizations with deep pockets and huge compute facilities, because this requires running the training task over multiple weeks, if not months. Since it is a costly endeavor, typically the retraining doesn't happen more than once a year. The training objective of these models is very generic. It is to generate the next token given a context. For those who don't know tokens, tokens are very similar to words, but not really words, because sometimes a single word may get split into multiple tokens. The outcome of the pre-training stage is called foundation model or a base model. However, you can't do much with a foundation model, apart from using in simple sequence to sequence tasks like translation, etc., because all it can do is generate next tokens. But if we want an LLM to answer user queries or to perform text classification or various other tasks, base models need to be trained on instruction datasets corresponding to those tasks. That's what is called instruction fine tuning. Very often, organizations that release base models also release the accompanying instruction fine tuned models, because base models otherwise are not of much use anyway. Instruction fine tuning is less compute heavy than pre training and therefore is done more frequently than pre training. Um, One thing that could set GPT 3.5 and GPT 4, etc., apart from the rest of the LLMs in late 2022 and through 2023, is the fact that the answers being provided by OpenAI GPT models were much more acceptable to humans than what the other models could do. Some of you probably are aware that it was made possible by OpenAI by aligning the model outputs with human preferences via RLHF. This is called alignment fine tuning, and it may involve a very large scale and time consuming human feedback annotation process, even though the training process may be less compute heavy. Today, many companies take other routes also to gather human feedback organically without needing to go through manual time consuming human feedback collation process. For example, by collecting human interaction data with the system. Okay. And finally, custom fine tuning is used by businesses or um, individuals to fine tune a model on their own private data specific for their business problem. Okay. Um, Various parameter efficient fine tuning techniques or PEFT techniques are used to optimize the compute requirements for training. And today, even smaller orgs or individuals can perform custom fine tuning on consumer grade GPUs. So what you see in this slide is the training loss for different versions of Llama 2 model during pre-training stage versus amount of processed data through multiple epochs. Llama 2 is open source model released by Meta for those who are not aware, and very recently they released Llama 3 also, right, which is being claimed as even more capable. Um, Anyone who looks at this chart on its entirety will conclude that the training process is going well. As you can see, the losses are coming down as we train more, and the larger the model, the lower the losses, because as we see, the 70 billion model has the lowest losses and the 7 billion model has the highest losses. So all is good in this chart, right? However, what if we focus on the first few days of the training? Mind it, this is pre-training, and hence the entire training process might have taken at least a few weeks. So what you see here at the top left corner might be worth a few days of training. And just by looking at this, can we really conclude whether the 70 billion model is, training is going well or not? It will be hard to conclude because initially all these models have very comparable losses. There might be spikes, which may or may not be caused due to bad data, which aggravate the problem even more. So you might have to wait a bit, give it some more time until the differences show up. And if there are any bugs or real issues in the code, you will have to redo the entire process once again from the start. That's costly because every hour of indecision amounts to thousands of super expensive GPU clusters sitting idle. Therefore, pre-training iterations for LLMs are super expensive and are not in the realm of consumer grade hardware that individuals or small startups may have access to. I'm sure many of you would have heard about the no free lunch theorem in the context of classical ML models, which essentially means that no single ML algorithm is in general the best performing algorithm for all problems. However, in case of LLMs, you can get more intelligence just by scaling more. That is, as you increase the number of parameters and the training data size, LLM accuracy tends to increase. Of course, you cannot keep training randomly because you need to provide the right data and use appropriate architecture. But scaling more clearly shows benefits. And this, of course, happens only after certain scale thresholds, as we have discussed in the very first axiom. But when it happens, it does happen. And researchers could show this empirically, as you can see in these charts. So, in case of LLMs, beyond certain scale, the no free lunch theorem doesn't seem to hold good. This is the final axiom. Some experts say that LLMs are strange, imperfect knowledge networks because no one really knows in full detail how the billions of parameters collaborate. What you see here is the heavily discussed transformer architecture that runs under the hood of all LLMs today. And the crux of this architecture is the attention block, which came into existence after the seminal paper named Attention is All You Need about 5 years back, which got awarded by NVIDIA about a few months back as the most impactful paper in recent times. A full discussion of transformer is out of scope in this session. However, what you see here is the functional view during the pre-training stage. Essentially, you can view it as a sequence to sequence mapping involving many matrix multiplications, where inputs and outputs are matrices of dimensions of batch size by embedding width by sequence length. And all LLMs, as of today, follow this architecture in the core. Of course, there have been some recent researches that in their bid to reduce the compute complexities of transformer-based models, which is in order of n square due to the self-attention mechanism, have explored state space models like Mamba, which is a linear time sequence modeling architecture with selective state spaces, and striped hyena, which is a hybrid architecture that combines attention and gated convolutions. But the results are way behind transformer based models. So the transformers are still the de facto architecture for all LLMs. Okay, now that we understand what LLMs are in terms of those four axioms, let's try to understand what hallucination is. There are many safety issues which plague LLMs. Some of them occur during training, some of them during inference, and some of them are related to overall governance. I have listed down some of the most prominent safety issues in different categories. And a discussion on these issues is not in scope for today's session, but one thing can be noticed that these issues may exist even within applications that don't involve LLMs. So these issues are not fundamental to LLMs. However, hallucination is not like any other GenAI safety issues. Hallucination is inherent to LLMs and their current architecture and the way they are trained. Why I say so will be clear in the subsequent slides, but we have to understand that currently it may be possible to detect or reduce or mitigate hallucinations, but we cannot avoid them completely. There are active hallucination techniques through various configurations like temperature settings, etc. But anyone who has tried GPT or any other LLMs can tell that these settings don't really solve hallucinations completely. So, what is hallucination? Hallucination is when an LLM generates output that seems plausible at the surface level but isn't. Hallucination is like a dream which seems real but isn't. In the middle of this slide, you can find content generated by an LLM for an Amazon product listing for a book, and it also has some ISBN number and may seem real, but actually no such book exists. So hallucinations may include factual mistakes or misleading outputs or fictitious citations or even fabricated output completions, etc. These issues cause lack of reliability and therefore are big deterrent to operationalization of practical LLM systems. And therefore, it becomes so important to mitigate hallucinations as much as possible. I have captured some common types of hallucinations in this slide. In the first example, the LLMs say, sky is blue today, followed by very bad weather today with gray overcast sky, which are contradicting to each other. This is called sentence contradiction. In the second example, the LLM says, the man held the pitcher with two hands and the camel with the other hand. Now, as humans, we know that a man can, only have two hands, and therefore it is illogical when LLM construes the third hand of man. This type of hallucination is called logical fallacy. In the next example, the prompt was to write a positive review of a restaurant, and the LLM writes, the food was terrible, the service was poor, which may be factually correct, but isn't in alignment with the prompt because we wanted positive review and it has given a negative review. Such hallucinations are called prompt contradiction. In the fourth example, the LLM says Barack Obama was the first president of the United States, and this is factual contradiction because this is simply incorrect. And in the last example, the prompt asked which country's capital is Paris, to which the LLM responded, the capital of France is Paris, which is right. But when, then it added on, Paris singer was known as the man of luxury, which may be true as an information, but is completely irrelevant to the given context. And This is called irrelevant generation. Broadly, these are the 5 categories in which LLM hallucinations can occur. Okay. So we now know what hallucination is and the different types of hallucinations that may occur. But we had gone through the fundamentals of LLMs and the axioms with the expectations that this background will help us to understand why LLMs hallucinate. So let's get to that. Hallucinations occur because we want to teach our models more and more abstract and subjective behaviors. What do I mean by that? Give me a moment. Uh, let's say that we have a simple traditional ML model to predict sentiment given a sentence. So if the input is poor service, we know that the target output must be negative. There is a single correct answer possible. There is no scope of any confusion whatsoever in terms of our expectation of the model in this particular case. Now let's take another type of task. The model has to translate from English to Bengali for this famous sentence, which is the last line from The Great Gatsby, a popular American classic. And since I know Bengali, I can tell that the translation is right. But can we not rephrase and write it in other ways? Yes, we can. And still, it might be correct because a sentence can be written in many different ways. So we see that there can be variability in terms of what is to be expected in the output. Now, let's take one more example where the um, LLM is asked to write a letter for this given situation, right? A 12-year-old daughter is writing a letter to a deceased his father, etc. So, can we really straitjacket the answer? We cannot, because there is no single based answer that exists in this situation. So, as we can see, we have over time expected models to move away from performing simple tasks which involved mathematically predefined objective function like MLE in logistic regression to much more complicated tasks which involve empirically learned objective functions like PPO or proximal policy optimization in techniques such as reinforcement learning. And that complexity forces models to hallucinate. And that's why we say that LLMs are designed to hallucinate, given the range of complex tasks that they need to perform. Um, right? Because, um, you know, many times there is no single based answer more often than not. If we delve a bit deeper, the usual data or training issues that plague standard ML models may also cause hallucinations in LLMs. For example, if your training data includes many sarcastic sentences juxtaposed one after another, the LLM may also learn to generate sentence like "Long live the king," followed by a contradictory sentence like "Till tomorrow morning," right? Which will look very similar to the sentence contradiction issue we discussed a couple of slides back. I have listed down some of the issues that may lead to hallucinations here. Some of them are related to data, like data insufficiency and imbalance, and data divergence over time, or divergence between training data and test data, and data quality issues, etc. Then there are inference time issues like input context issues and the balance between coherence and creativity, which settings like temperature are expected to control um, as much as possible. Then there are training issues due to which overfitting and encoding decoding mistakes creep in. And there is the lost in the middle phenomenon, because of which LLMs tend to forget contents in the middle of large texts much more than the start and end of the texts. But even if we solve all these issues, hallucination won't be avoided completely, primarily for three reasons. First, LLMs are typically not used to accurately predict a fact, but rather to follow a cognitive and linguistic path to provide output. Second, LLMs are not knowledgeable. In terms of they are not knowledge management systems, they are storytellers. They are expected to construct a reasonable completion to a given prompt, which makes their output very subjective in nature. And third, LLMs are trained on large corpus of free-flowing data. LLMs have a free-flowing understanding of how humans use languages. So contradicting or constricting an LLM to bring narrowness to the output is a non-native idea for LLMs. Of course, RLHF is one approach to bring some control to LLM outputs, but it is far from being completely successful at eliminating hallucinations. Now, before we understand how we can reduce hallucination, let's understand how we can measure hallucinations. In the next few slides, I have listed down some commonly used metrics for quantifying hallucinations and bucketed them into a few broad categories based on the approach. I have included pros and cons of each such metric and also the links to the respective original papers. And you can actually use some of them in your projects or um, business applications. Um, First category is n-gram overlap, which is based on number of words overlapping with some ground truth. These are lexical metrics. For example, blue checks the precision of n-gram overlaps adjusted for brevity and is suited for machine translation kind of applications. Whereas Rouge N checks the recall of n-gram overlaps and suited for summarization. Both of them rely on exact matches, whereas Meteor uses a weighted average of unigram precision and recall and does not require exact match um, because it allows for synonyms and word stemming, but it expects specific word orders. Okay. Meteor is especially suited for image capturing kind of applications. The next category is based on semantic similarity as implemented by metrics such as BERT score and BlueRT, etc., which rely on semantic matching rather than lexical matching. These techniques are especially useful for validating citations that LLMs might come up with. However, all these metrics discussed so far from both these two categories require ground truth data, which may not be available always. This brings us to the third category where no ground truth is required. And the metrics are based on benchmarking datasets. Pika and HelaSwag focus on multiple choice answers and are useful for common sense reasoning in QA. Lambda focuses on last word after a long context and is useful for in context learning kind of use cases. For code generation or documentation or bug fixing kind of use cases, Human Eval and Codex Glue might be found useful. Then there is HalluEval, which focuses on identifying the degree of hallucination and hallucination recognition performance of LLM systems. The challenge with these metrics is that they rely on benchmark datasets, and therefore metrics on your dataset cannot be computed using these approaches. The next category is based on self-verifications performed by LLMs and therefore neither requires ground truth data nor relies upon benchmark datasets and hence has a broader real world application but is more expensive because more tokens are used. These metrics are useful for RAG or retrieval augmented generation for a large variety of tasks and in context learning kind of use cases. However, these methods lack explainability, right? G-eval relies upon LLM responses, rated by GPT-4 via chain of thoughts approach. Self-check GPT relies upon zero-shot entailment score of multiple responses from the same LLM for a given input. Ragas is quite comprehensive and is worth looking into. It gives a set of metrics based on four different dimensions: answer relevance, faithfulness, context precision, and context recall. Context recall with ragas requires ground truth data, but other dimensions don't require. Please note that these methods require the prompts to be tweaked around based on business specific requirements, right? Then there is ARIES or automated RAG eval system, which considers three dimensions: context relevance, answer faithfulness, and answer relevance. The advantage of arrays over the previous metrics in this self-verification category is that it is robust against domain or task-specific requirements. However, it achieves that by way of an LLM judge fine-tuned on a small amount of human annotated dataset, which makes arrays a more complicated process overall. Then there is SAFE or search augmented factuality evaluation, which is useful for long form responses in open ended topics and open domain. SAFE can leverage either search APIs or internal database based search and requires neither benchmark nor any ground truth data. However, for business tasks specific to domains, this method may not work well. The next category is token probability based and is applicable only for LLMs which give out output token uncertainties. We cannot use these methods with commercial LLM APIs because they are closed source and therefore don't give out the output token uncertainties. Also, the scores here indicate model confusion rather than true hallucinations. Examples include GPT score and semantic entropy. On the advantage side, these methods don't require any benchmark data sets or ground truth data, and they are robust against domain or task shifts because these are not prompt based methods. The final two categories are useful for LLM ops and scenarios that involve comparison among multiple LLMs or selection of LLMs. There are many big players like Eleuther, Copilot, OpenAI, MLflow, BigCode, etc., who have leveraged various different benchmarks and metrics we discussed earlier to come up with evaluation harness. On the other hand, various pairwise comparison metrics such as Chatbot Arena, ELO from Cohere, don't conflate, by the way, with the ELO chess rating, etc. It is modeled around that system, but it's a different for LLM comparison. Cohere released a ELO paper, right? And negotiation arena focus on ranking LLMs on specific capabilities. Okay. And now that we understand how to measure hallucinations, let's get to how we can reduce hallucinations. There are many papers published during the last 1 year or so on various strategies to reduce LLM hallucinations. Please don't worry if you are not being able to read what's there on the slide, because a detailed discussion of these papers anyway is not the focus here. I have kept them for you to know the depth and breadth of hallucination techniques out there. It's an active area of research, and some broad taxonomies of the methods proposed by the researchers are present in this slide. Some of them focus on improving hallucinations by enriching the data during training. Some others focus on improving the training process itself. And yet some others focus on techniques at the inference time to mitigate hallucinations. As I mentioned in some of the previous slides today, pre-training and even instruction fine-tuning are costly affairs. Alignment training requires huge annotation efforts and hence is not very suitable for organizations or individuals with limited budget. And the marginal improvements in hallucinations with custom fine tuning over inference time techniques are not yet found to be commensurate with the corresponding increase in cost if we consider the increased compute complexities involved. And hence, in the rest of the slides in today's session, we'll focus on inference time hallucination mitigation strategies, because that's what gives you the best bang for the buck for implementing real world budget friendly business applications, which the practitioners like you should know about. These are some common hallucination approaches, hallucination reduction approaches at the inference time. Active mitigation by controlling LLM settings like temperature in case of GPT can reduce hallucinations but cannot detect. And we have already mentioned earlier that this method is not fully reliable. In order to force structure out of any language model completion, some of you might have used regex in the past and more recently LangChain's structured output parser. But these techniques are useful only if the raw output from the LLM is not hallucinated, because otherwise, forcing a structure by itself doesn't guarantee hallucination removal. Next, RAG, that is retrieval augmented generation, which is a buzzword these days, helps LLMs to generate output grounded on business specific contextual information. RAG helps to reduce hallucinations to a large extent, especially with one shot or few shot prompts. But since this technique neither detects hallucinations nor gives any off the shelf metric to quantify the degree of hallucinations present in the output, you don't know whether a specific output has hallucination or not. Then there are companies who sell LLM evaluation platforms which can detect hallucinations via post generation evaluation prompt templates, but the metrics they provide are valid for benchmark data only. The next technique involves cross encoder entailment for hallucination detection. Cross encoder entailment means early interaction between the embeddings of two different texts, which is different from approaches such as cosine vector similarity after you have got the embeddings, which use late interactions of the embeddings. I have included a link to a notebook here to show how it works. Let me open the notebook. Um, as you can see here, I have used cross encoder from sentence transformer with Victora's hallucination evaluation model. Right, that's the model that I'm using here. Victor is known for its vector DB solutions and a competitor to other solutions like Qdra and OpenSearch, etc. They also released this model. As you can see, it can provide a hallucination score for any given input text pair. It is a semantic similar based score. So the lower the score, the higher the hallucination. If we assume a cutoff at zero point 0.5, the scores seem to work fine for these examples here. For example, uh, the senior guy in my neighborhood drives once a week, this sentence, and all persons who drive once a week are aged are not really the same thing, right? And therefore, the score is 0.36, which is lower than zero point 0.5. And therefore, we detect hallucination here, which is correct. Um, in the next example, however, the two sentences are similar, and therefore, the score is higher than zero point 0.5, and no hallucination is detected. And then in the third example, the sentence completely contradict each other, right? And therefore, the score is very low, and hallucination is detected. However, the primary challenge in this approach is that you either, need a ground truth to begin with, which is difficult to get, or you need to generate multiple outputs for the same input prompt to find out an aggregated hallucination score, um, for randomized pairs for each prompt, which is time consuming and costly. Let's get back to the slide now. The next approach involves traceability through citations for the output generated by LLM, and you can use some similarity metric between the generated text and the cited text to identify the reliability of the citations. Then there are observability solution providers who have their closed source implementation of proprietary algorithms to detect hallucination, and they also provide off the shelf metrics, but these are commercial options and therefore may not suit everyone's budget. The next technique is about Nemo Guardrails Toolkit, which was released by NVIDIA last year. It's an open source framework for easily adding programmable guardrails to LLM based conversational systems, and it supports multiple LLMs. It is a framework, and the developers are expected to write the configurations appropriate for a business context. Therefore, the configurations may change depending on the business context, and it is as good as the developers who are using it. If the developers can use it wisely, it is good. The last one in the table is COVE, or chain of verification method, which was released by Meta, and it gained a lot of traction because this technique helps an LLM to verify self-consistency by itself. I have the next slide to explain the COVE method in more detail, especially because of its popularity. The COVE method involves 4 steps. Let's assume that the query is name some politicians who were born in New York. Step 1 is to generate an initial draft response or a baseline response like we see here. Step 2 is to plan verification based on that baseline response and the original query. Once the plan is generated, each of these verification um, questions are executed independently by the LLM and the corresponding responses are generated. From these responses, the final verified response gets created. As you can see here, Donald Trump, which was present in the baseline response, will now be removed because it has been proved to be incorrect in the verification stage. So that's COVE method. The challenge here is that it is time consuming as well as costly, but we use use cases where reliability is paramount. Such costs can be budgeted for, where COVE is used. This method is one of the most popular techniques for inference time hallucination reduction. And so I have included the link to a notebook to highlight a typical COVE implementation using LangChain and OpenAI APIs. Let me open the notebook, right? First, we do basic setup like installations, imports, etc., and then we load the LLM with our own keys. We are using OpenAI here. Now, the query is very similar to what we just discussed. We follow similar steps. We generate baseline response followed by plan verification using this template, right? And then we execute these verifications. Um, So one more relevant point to mention here is in the third step, that is the verification execution step, has been implemented in this notebook with 2 different approaches. The first approach is where I have used the same LLM to do it, and the second approach is where I have used a search engine API to do it. For search engine, I have used DuckDuckGo API, but you can use anything else that you may like. And then finally, we have generated the final response. So overall, within the overall, broad construct, you can play around with your own customized approach that works for your own business problem. Let's get back to the slide once again. Okay. So as you can understand, uh, good uh, implementation will need to leverage appropriate hallucination techniques as well as um, evaluate it using the right metric, because most of the standalone hallucination reduction or detection approaches don't come with any of the off-shelf metric. That's There's no one size fits all. So in this slide, I have collected a few examples of how Insight Out, the AI startup I currently work for, has implemented hallucination mitigations. I have shown examples across three different types of tasks across three different industries in multiple regions for both open source and closed source LLMs. The first one is a proprietary customer conversation intelligence framework we developed at Insight Out, which is currently being used by some of our automotive and telecom clients in the APAC region. We used an auto-extracted alias curation approach for better coverage of brand-specific keywords in multilingual transcriptions and chain of thought based detection of hallucinations in RAG responses with the help of G-eval metric. For traceability purposes, we included verbatim citations, and we leveraged them for hallucination detection by using word score metric. And then the overall system was evaluated using Raga's metric. The second one is an example of insight extraction from internal market research documentation for an European FMCG client of ours. Here we used a four-pronged approach modeled around COVE. First, we pre-filtered relevant documents based on metadata pre-extracted by LLMs prior to doing RAG, so that RAG search space is optimal. Then we auto-formulated hypotheses based on RAG responses and then validated them by searching through clients' internal structured data, selected only those with safe metrics, which we studied, right? Finally, multiple iterations of the same user query were sampled, and hypotheses with lower self-check GPT metric were discarded as unfounded. The last example in this slide is of a natural language query assistant for SQL data of an European pharma client of ours. Here, the client specifically wanted to use open source LLM instead of any commercial API due to privacy concerns. Since the table structures could not be known in advance, we extracted the table schema using LLM for auto inclusion in the system prompt prior to NL to QL conversion. Then we generated um, the SQL query from the user query using SQL coder from Hugging Face, and we validated the generated query to ensure coherence with column names and data values for auto-detected keywords. For transparency and traceability purposes, we also allowed the users to review and modify the generated queries embellished with confidence scores before we executed the queries for final results. Human eval and codex glue metrics were used to evaluate the overall system. Okay, so that's the overall, hallucination mitigation. It's an active area of research, and you need larger applicability, observability, and traceability, and higher semantic coverage and real-time uncertainty and confusion scores for an ideal hallucination mitigation technique, right? And here is the summary of what we learned. The top key ways are: we understood the fundamentals of LLMs and why they hallucinate. We went through the implications of hallucinations and how hallucination is different from other LLM safety issues. We learned about metrics used for measuring LLM hallucinations and their respective pros and cons. And then finally, we learned about some hallucination mitigation strategies for implementing practical business applications. And then we saw real life examples of how these strategies were implemented at Insight Out. Okay, so that's about it. Thanks for listening in. I took, I think, one more minute than to a schedule. Let me just see if there are any questions now. Let me go to the Q&A, right? Um, may I know the prerequisites to attend this session? Can this, okay, this is um, I think was a question long back probably. So can this course be provisioned for Gemini and Bingo? No, we are not provisioning anything here. Essentially, you can use actually Gemini. There are free tokens you can get. So you can use Gemini using your own um, account also, right? And utilize the free tokens. How will this course be useful for real-time projects? How do you project these skills for job opportunities in a short period of time? As I mentioned, this is I talked about many real-time projects, right? I mean, we something that we have done at Excite Out, and if you know all these techniques, you will be able to handle hallucinations much better, and therefore you'll be able to design your LLM based GenAI um, business applications way better. Otherwise, anyone, Tom, Dick, and Harry can just use OpenAI based API and create something, right? And when it is used in practical applications, there'll be a lot of misalignment in terms of the answers, etc., etc. Right? So you have to know how to reduce hallucinations, and in real industries, that's what you do, right? Okay, so these are the two questions. I think that's all. Thanks for listening in. I think, and thanks, Ekta.
Kaushik, I think there are two more questions in the chat. If we can open the chat.
Okay. Um, okay, so I see, yeah, a couple of six. Okay, question you can post. Okay, what is role of transformer in generative AI? Well, I mean, all the LLMs are, as I mentioned, based on transformer architecture. All LLMs and LLMs are driving generative AI. So that's the role of transformer, right? What next topic on GenAI you are planning to conduct webinar? Well, that's a
Yes.
thing that
So,
probably TimesPro should think about.
yeah.
Yeah, yeah.
So, we will be coming up with more, topics into Gen AI, wherein you get proper, different topics covered along with the career aspect into this. So, thanks, Mr. Kaushik, for this. We hope this webinar has really sparked everyone's interest in the vast potential of this field, but I think but how you can gain this knowledge and turn it into a real advantage. So we as a Times Pro, we have our comprehensive program, which is IIT Mandi's certificate program in applied artificial intelligence and machine learning. So this will be a 6-month online program, and it offers a unique opportunity to gain industry ready skills for everyone, right? So the course, just to give you a brief idea about the course, is it has around 120 hours of live online session led by expert faculties from IIT Mandi. Also, it has a vast curriculum that will cover everything from Python fundamentals to cutting edge topics like AI for speech processing and computer vision. And you'll also get hands-on experience through assignments, case studies, projects, and also there's one campus immersion which is included, and that will be at IIT Mandi, to network with your peers and faculty. And of course, upon completion of this program, you'll get a certificate which will be a joint certificate from IIT Mandi and Times Pro, adding a prestigious credential to your resume as well. So, I think whether you are a graduate or a seasoned professional, you can obviously visit this program link once and check if this is right for your eligibility. I will be posting the program link into the chat. So, anyone, if you want to just go through the program, you can go through the program once. I'm posting it into the chat. for
Yeah,
every
and in the
person.
meantime, I also see one more question from Randy. What programming
Yes,
languages we need to have expertise and so that we can get full hands-on on LLM in future? Please
yes,
share your views. So yeah, I mean, Randy, Python SQL is must, and you should know PyTorch. That's, I mean, you can get started with these three good enough. I mean, yeah, yeah.
sure. So I think that was a really great and knowledgeable session, and I would like to thank our esteemed speaker, Mr. Kaushik, for sharing his invaluable insights and expertise with us today. I would also like to thank each one of you for, you have been a very attentive audience for today's webinar, and we have many more sessions on Gen AI also and other technical topics which are planned in the coming months and weeks. So you stay tuned with Times Pro, and thank you all once again. Thank you so much.